intercepts and transversals. Linear intercepts is just another way to write an equation for a graph. So we're going to find an equation for the line shown. As usual, we're just going to start with y equals mx plus b, just our empty sort of line template. What can I see just by this graph? Can I see m and b? Can I see both of those things on this graph, m and b? Any ideas, Pablo? You can get m, but you can't get b, right? Because I can't see, this line I know crosses the y-axis somewhere down below. It's not in the graph anymore. But we can get b just from the picture because it's just a slope, right? So we can look at rise over run. I put these smiley faces so you guys could see the actual points. When you guys do this, you want to make sure that you're using an actual for sure point on the graph, as in a point where it crosses exactly through your two grid lines. Don't just pick some point that doesn't look very nice. So these are all nice points. I'm going to go from this point to this point to find my slope. So I like to think of slope as rise over run. So if I do my rise, I go up 1, 2, 3, 4, 5, and over 2. So this was up 5. This was over 2. So what is my slope going to be? PJ, what's my slope going to be? 5 over 2, good. So I have y equals 5 halves x plus b. Now, just like when we solve normally, you guys have been solving for many different types of lines, we just have to use a point that we know for our x and our y coordinates, and we can solve for b. So I'm going to use this point down here, which is 2, negative 6. And I'm going to plug it in for my x and my y to find my b value, which is the next thing we need for our equation. So my y point is negative 6. I'm going to carry out my 5 halves. My x is 2, and I have plus b. I can make this 2 over 1, and these 2's cancel, super nice. So I have negative 6 equals 5 plus b. We want b all by itself, so we have to subtract 5 from both sides. I'm sure you guys all feel pretty confident with solving for a b. You guys have been doing it for a while now. So I have my b, I have my slope, but this is just like all the other line problems. Your final answer should always be the equation. So y equals 5 halves x, and we're going to have our new b in there, minus 11. So we use this method when we can't see that the y-intercept, so the b value on the graph. We have to use the slope, and then we'll solve for our b. All right, give you guys a second to draw this picture. All right, so Jasper, how do I know what this little angle right here is? Yeah, so they're supplementary angles. So I'm going to call this little angle x. 114 plus x equals 180 because of supplementary angles. So if I subtract 114 from both sides, I'm going to get the x is 66 degrees. So I'm just going to erase my little x, and I'm going to make that 66 degrees. Whoa, crayon. That was weird. 66 degrees, great. Now that I know this angle, I can figure out what this angle in the triangle is. Jeremy, what's this angle in the triangle going to be? Not this one, sorry, this one. How are these ones? Yep, and how do you know that? It is. Yeah, Pablo, what's the reason? Yeah, they're corresponding angles. We use Cora for that. So now we have that little angle down there, and we're going to use our friend SOHCAHTOA to find n. So I have my 66 degrees. Is this 100 my hypotenuse, adjacent, or opposite relative to my 66 degrees? Everybody shout it out. Hypotenuse, thanks. Great. All right, how about n? Is this my opposite or my adjacent? Opposite, great. So opposite and hypotenuse. Something that might be helpful for you guys, Whenever you're doing these triangle problems, when we're labeling our triangle, we always want to label what we know. So we're given the 100. We also want to label what we want to know. So we want to know what n is. This little bottom value, which is actually our adjacent side, we don't really even need. So you don't have to label that in your triangle. That way we know that we have to use the trig function with O and H in it. So what's the trig function with O and H? Sine. Great, so now that we've labeled it, we can come up with an equation to solve for n. So my equation is going to be sine, our angle always comes right after sine, equals opposite over hypotenuse. My opposite is n, what we're solving for. My hypotenuse is 100. And this is one of the easy ones. I can just multiply both sides by 100 to solve for n. And someone plug that in for me. N equals 100 sine 66. Pablo, what'd you get? 91.355. Did you get the same thing, Brody? Sweet. All right, not too bad. We're just putting stuff together. Going to find this angle, and then we use a trig function to solve for our unknown side. Let's try one more. So we know that lines 1 and 2 are parallel. So if we wanted, we could put in these little arrows that tell us they're parallel. Find sides M and N. So finding side n is going to be really similar to what we did last time. Now we just have to find m as well. So I'm going to start by using the same process to find the angles. So this angle and our 158 are supplementary with each other. So 158 plus, we call it x again, equals 180. So x has to equal 22 degrees this time. This is 22. And then again, using corresponding angles, this angle is going to be 22 degrees. Now I'm trying to find m and n, so I'm going to go ahead and label the whole triangle. So just like last time, 90 is going to be my hypotenuse. It's across from the right angle, so I know it's my hypotenuse. Last time we also decided that n is opposite because it's directly across from my 22 degree angle. The only thing left over is adjacent, so my m must be adjacent, which sounds good to me because it's right next to that angle. So whatever is right next to the angle is going to be my adjacent side. Now we're going to set up some equations using SOHCAHTOA again. SOHCAHTOA to solve for m and n. So I'm going to start by writing an equation just like last time because I remember doing that from my last problem. So in order to find n, we used opposite and hypotenuse. So we were using sine. So sine 22 equals n over 90. Another pretty easy one to solve for, so I'm going to multiply both sides by 90. And n equals 90 sine 22. What'd you get, Brody? 33.715. Great. Now I want to solve for m down here, and I know the hypotenuse still. So what trig function should I use to solve for m? Adjacent and hypotenuse, Emily? Yeah, cosine. I want adjacent, and I have my hypotenuse, so I'm going to use cosine. You could use what you solved for here. It's just going to be less accurate because we rounded there. So you might want to use what was given to you, this nice number from the very beginning. But since we know the other side, you technically could use the other one. All right, cosine 22 equals adjacent, which is m, over hypotenuse, which is 90. We multiply both sides by 90 this time again. And we get that m equals 90 cosine 22. What does somebody get when they plug in 90 cosine 22? Pablo? 83.447. We look at both of our sides. M 83.447 seems like it works because it's 90. N 33.715 seems like it makes sense also. If you guys get numbers that seem really, really strange, you might want to double check your math.